Hey everybody, my name is Jonah Fitzgerald.
What is
What
it?
is-
Oh, you're on the Discord? Thanks, Jacob. Jonah Fitzgerald, social media chair. It's not showing. What do you see?
Discord.
What do you see?
Discord.
Are you kidding me? Okay. There we go. Let's try that. I don't think that's supposed to be right. What do you see?
Black.
While I'm figuring this out, does anyone know anything about Bash? You don't count. So on different systems, there's a program that will take your commands and then issue it to the operating system to run. That's called a shell. It's a very important definition because that means that the terminal you use to actually do the commands is not the same thing as a shell. And I'll show you all that in a little bit. I don't think it's gonna work, Jacob.
Yeah, it'll be okay. Never mind.
All right. So yeah, shell, terminal, different things. So if I go to these two terminals over here, on the right there's a different terminal, on the left is another terminal. If I type in sh, I'll be in a different shell from bash. Again, it's just another program for issuing commands to the operating system. They do effectively the same thing, it's just everyone loves bash because it's really cool. We also love bash. Why would you want to use bash or really any shell program for running commands? Well, for one, being able to talk to your operating system is a very powerful feature. Bash also gives you some different control flow mechanisms like if-else statements, while loops, gives you environment variables for your programs to like use while they run. Very useful for automating tasks like building programs, installation, and creating any kind of tools that you might not have available. What happened? It was not supposed to just close automatically like that. We're going to go ahead and get started with our first example. Follow along if you're on Linux. If not, you can also use Windows Subsystem for Linux for bash scripting. Otherwise, just feel free to take some notes. First thing I'm going to do is open up a new file. Cover it. Okay. First example we're going to go over is something called the Collatz conjecture. A conjecture in math is just like a theorem, but it hasn't really been proven mathematically yet. But we kind of like know this is true. Because if you follow these rules, take a number, if it's even divided by 2, or if it's odd, multiply by 3, then add 1, and just repeat those steps over and over again. Eventually you will get the number 1. We're going to go ahead and write a script that will actually do that for us. Okay, so I'm in a file. I called it collatz.sh. The first thing in any bash script you do in order to start issuing your commands to the operating system and automating your commands is you use something called a shebang. Shebang. So, can y'all see that fine, by the way? Good? Awesome. So what that does is tells us what shell we want to use, right? Because again, we have lots of different shells, like bash, and that shebang, that's what they call it, is going to help us determine which shell we actually want to use to execute these commands that we do. And then right underneath that, I did a comment, so we don't want to actually execute that. Okay, so the first thing we want to do when we're doing the Collatz is get a number. We just want to get a number from a user. And in Python, that would look something like this. Let's say num is equal to, let's say print. What number would you like to test? And then in Python, you would save that to a variable, something like num is equal to input. Right? And so we're going to pretty much do that in bash. We're going to echo what number would you like to test. Echo is the first little command that we'll learn about. It's basically the print statement of bash. You give it a string and it spits it right back out. And then we're going to learn about the read command. So kind of like the input command in Python, it'll get input from the user. And then right after the word read, you'd want to use, let's say, num. And so what that will do is echo what would you like to test, and then it will read from the user and then save that into a variable called num. Pretty straightforward so far. Let's see. So the next thing we want to do is keep track of how many steps we do for collats. Because we're going to do the, if it's even, divided by 2, if it's odd, multiplied by 3 plus 1, a bunch of times. We want to try to keep track of how many times that happens. Let's see. Total steps. Now comes the first little quirk of bash, as I call it. So we're going to go ahead and instantiate a variable. When you're creating a variable, you name it, and then you follow it immediately by an equal sign, and then by whatever you want to set it to. I'm going to set it to 1 in this case. If you were to try to put spaces between your command and the equal sign and whatever you're trying to set it to, it'll give you an error. Let's see what that error looks like. What I just did was change the permissions to execute the file. I'm not really going to go into what permissions are in Linux. Just know that if you wanted to execute it, you would run that command. And let's run it. Okay. Let's try adding some spaces. See if it'll get upset with us. Okay. So yeah, because we added some extra spaces between the equal sign, it got mad at us and thought we were trying to run a command, but it doesn't really know what that command is. So make sure you take out those extra spaces. Okay. Now we're going to do a while loop. While loops are fun. Let's see. What do we want to do? So all while loops will start off kind of like this. Can y'all see that, by the way, that orange color? Not really? Let's see if I can open up a different editor. All right, that should look better. Okay, so all while loops will start off kind of like that. You say while, then you'll have some angle brackets, and then do. Let's zoom in a little bit. And then anytime you want to kind of close a while loop, you'll say done. And then anything in between the while and the done, you'll just run over and over again. So now we get into one of the other quirks of bash, is conditional expressions. So inside of those angle brackets, we're going to try to evaluate some expression to see if it's true. And while it's true, we're going to run the code that's between the while and the done. So the funny thing about bash is that it doesn't rely on Boolean statements in order to run something over and over again. It relies on status codes. So each time you run a command in your terminal or in bash, let's say echo hello world. You know that ran successfully. It'll have a status code. So did it run successfully? Was there some super serious error we need to worry about? To get the status code of that previous command, I'll do $, question mark, and then it says 0 command not found. Just know that 0 is a good thing. We want the status code of our programs to be 0. Let's do our first conditional expression here. Let's see. Let's just say 2. We'll do 2. Okay, so that kind of looks a little weird. Anytime you're doing some sort of conditional expression in bash, you'll start your angle brackets, and then you'll have some operators. So let's say the 2, and then in between them you'll put a flag. So in something like Python, you would do 2 double equal to 2, right? And that would return bash. You will set angle brackets, the operand, and then you use a flag. In this case, dash EQ, and then that will return status code. In this case, it would be 0. There's like a ton of other flags too. There's like E greater than, less than, etc. Don't memorize them all. Just if you ever need a flag other than that one or those, just look it up. Because there's like 200 of them. Okay. Let's get back to this. Okay, so we want in these angle brackets an expression that will return a status code of 0, meaning it runs perfectly fine. So let's say while num, because that's the number that we got from the user, is not equal to 1. One of the other quirks of bash, so you see I typed the word num, that's my variable containing the user's input. If you want to actually get the value out of num, not just the name of it, you'd have to put a $sign in front of it.
I have a question about the 2 equals 2 thing.
Yep.
When I type it in, I get bracket 2 command not found. Just on the shell. Is there something I'm missing here?
Bracket 2 command not found. Did you put a space between the bracket and the 2?
I did not. Okay, I guess you have to put space on both sides.
Yeah.
Okay.
It's real particular about its spaces. Let's see. So now that we have a number, we're going to repeat. Check. Yeah. So over and over again, we're just going to check if our number is 1. Then if it's not, we're going to say if it's even, then we're going to set our num equal to num 2, odd, num equal to num +3. So we're going to try to run this over and over again, constantly changing our num. Okay, so we're going to start an if statement. If statements kind of follow the same quirks of while loops. I'm going to say if, angle bracket, and let me just leave that blank for now. And then I'm going to close it. So anything between if and then is going to be ran in this if statement. So now we kind of have to do some math. And math isn't very fun in bash. So we have angle brackets. That's a conditional statement. And then when we want to do math, we do double parentheses. Also say integer math. So math specifically for integers. Bash doesn't really like floating point numbers. Okay. So inside of this if statement, we're going to check if the number that we got from the user is even. Okay. So I'm going to start off with double parentheses. Kind of like we did above. I'm going to get the value from num. num. And then I'm going to say modulo 2.
Can there be spaces there or no?
I don't remember. I think there can be, actually. I think it can be because we're going to do something kind of funky. I'm going to put a $sign in front of that. So even though math expressions use double parentheses, anytime we want to like take a value and insert it into our command, we're going to have to use a $sign in front of it. $sign parentheses. So anytime you want to insert some sort of math value into your statement, you're going to have to put a $sign in front of it. And that is indicative of something called a command substitution, which is a more general form of that. So if I say, let's say, echo So this statement is a lot like the Python statement. Print, let's say, right? This is what, these are analogous. This is Python, this is Bash. And the reason why you want to do this in Python is because, well, we don't actually have to save the string hello into a variable, right? I mean, we can, it would work the same, but we don't have to. We can substitute it into the command. And it's the same thing here, right? I can just substitute a command that returns, say, this string, and put it into this bigger command. And that's what's happening with this if statement. So breaking it down, so far we start a conditional expression, conditional command. We're going to do some math, and we're going to substitute it into our conditional expression. And what do we want? So if the num is equal to 0. So remember the modulus operator, that'll return the remainder when you divide something. If a number is even, the modulus of the number and 2 is 0. And so what do we want to do? We'll take our num variable, kind of like in our steps to the right. And then I'm going to have to do a command substitution here. Let's say num divided by 2. Okay.
So you only use a $sign when you refer to the variable but not do an assignment?
Yes. Again, it's another little quirk. If you're referring to the variable just as itself, then you don't need the $sign. But when you actually want the value that's inside of it, $sign. So again, we're pretty much doing the same thing we did in our if statement. We're just doing some math. This time we're taking the value out of num, dividing it by 2, and then we're putting it into num. In this case, we can do an else statement too, because if a number is even, then it's even, but if it's not even, then it has to be odd. So thankfully, we don't have to do another expression like that again. Is equal to $sign double parentheses because I'm trying to substitute some math into my command. Then I'm going to multiply num by 3 and then add 1 to it. Cool. And then, so now that we've pretty much done all of our steps for doing this, we pretty much just want to return the result. Let's say echo let's see, the steps needed to get to 1. Total steps. Okay. So if you notice in that echo statement, I started as a string, but then inside of it, I actually get the value out of total steps, right? If I wanted to just refer to the variable by its name, let's say the steps needed to get to 1 found in our total steps. I wouldn't put a $sign in it. Oh, you know what we forgot? We need to increment our total steps. So going back into our if-else statement, let's say, where do I want to put that at? You don't need to put it there. Let's put it above the if statement. Let's say total steps is equal to, do another little math substitution. Total steps plus 1.
There's no plus plus equivalent?
There is not a plus plus equivalent in bash. Yep. Anytime you want to do math, you're going to have to do these double parentheses things. I forget the exact reason why, but I think it tells it specifically to go into some sort of mode where it knows how to do math expressions. Because if I were to go back into my terminal and just say 1 plus 1, it wouldn't actually do anything. But if I said 1 plus 1, it would work. Let's save it and run it, see if it actually works. Let's see. Cool. Okay, so I gave it the input 5. And so in this case, my first step would be to check if that's equal to 1. It's not, it's 5. So I'm going to increment steps by 1, so it's 1 step. And then I'm going to follow our procedure over there. So 5 is odd, so then I'm going to do 5 times 3 plus 1, so that's 16. And then we increment our steps counter again. 16 is even, so I'm going to divide it by 2. 8. 8 is even. Divide by 2. Even. Divide by 2. Even. 2. And then the last step is to check if it's 1. And oh look, it's 1. And it took us 6 steps to get there. So that seems to be correct.
So it's relying on you eventually getting the power 2 and then write it down pretty much?
That's right. And yet no one's proven it yet. Let's try with an even number real quick. And 3. So it says we take 3 steps. That's 1, 2, 3, and that's right. Okay, so that was kind of a lot. Does anyone feel intimidated by this? All the extra parentheses and angle brackets. Heck, before I got into programming, I had hardly hit the angle bracket key in my life.
I feel like this is something you can learn and then leave it alone and then have to completely relearn unless you do this like all the time.
Oh, yeah. Okay, so what did we learn from that example? Well, probably nothing because like me, bash just kind of goes in my head and leaves the next day. Like Dr. Cherry said, it's kind of like, I don't know, kind of difficult to learn really. But from that example, we learned about control flow, so we had a while loop, if else. Then we learned how to get user input, and then we learned how to do iteration. So with the while loop, we could take that counter and increment it. I had a recursive example, but I'm not going to torture y'all anymore. And then we learned some of the basics to substitution. Cool. How are we doing on time?
6:30.
6:30? How long did you want this meeting to go for that, like 2 other examples?
However you want to go.
I'll do one more.
Cool.
Here, quick question.
Yep.
It seems like if you take away the dollar sign when you're inside the double parens, it seems to still be okay with that. Like you do dollar, double paren, num divided by 2 without the dollar sign, it still seems to stand the variable.
Oh, really?
I'm not seeing any difference.
Let's try that. So kind of like that?
Yeah.
Wow. You learn something new about Bash every day. So I guess you can do it either way. It's up to...
Just the that mode, that math mode.
Right. Interesting. Cool. Well, let's move on to another example. Info.sh. Okay. So, like Jacob said, we're at 6:30, so if you need to leave, feel free to leave. This next one is going to be a lot more boring than that previous one. It's going to deal with text processing. So, for the most part, what that previous example did was it basically showed you how to take status command, do a little bit of math, do some control flow. And that's mostly what people will use it for, because Bash is very good at process management or just doing simple tasks. But if you want to do something a little more complex, like write some tools that you don't have, write some tools that you don't have, then you can use Bash. So this next example deals a lot with very narrowing down what piece of text you actually want. So, little networking interview overview. I'm going to be getting a lot of this information. So you have a computer. That's what a computer looks like. And a lot of times it will be connected to a router. That's what routers look like. And that connects to the internet. And this is all one network. So anytime you're in a network and your computer is connected to, say, a router, it'll get a local area IP. And then your router will also have an IP. We'll call that the gateway. Because anytime my computer wants to talk to the internet, it has to go through the router. And then our network also has its own network. I'm just going to call it network IP, but address range. So addresses for all of the computers on the same network are similar. And let's see if we can get all of that information automatically. The reason I say that, some people will use ifconfig to get their information. Some people will use IP address to get their information. Some people will have a very small output, but as you can see from my terminal, I have a ton of output. It's hard to find what I actually want. So it'd be very helpful for me to just automatically get this information right away. Okay, let's start writing a script for it. First thing we want to do, the shebang. Let's go ahead and change the permissions on it. So the next thing we want to do, let's say we want to do it on a device basis. So if I go back to that horrendous output that y'all saw, around here, you'll see a device called, well, you probably don't see it at all. It's probably horrible to see. But this represents my Wi-Fi adapter. So anytime I'm talking to the router, that adapter will be talking to it. And it'll be what gets the IP address. I don't know if you can really see it right there. So let's see if we can grab that. So let's see. The address. Cool. So the IP command will do a bunch of different things networking wise for your computer. Use a different marker. And then the address command right after that, that's going to get all of our addressing information. And then I want to show the addressing information for a specific device. And that's the specific device. A lot of people's will look something like this. Or maybe just this. If you do just this part of the command, you can look for it. So now that we know how to get that massive body information, let's try to narrow it down. Let's see. So let's see if we can put all this on one line. Cool. Okay. So that -O flag, that will put it all into one line for us. So anytime you're inside of the terminal and you're doing commands, commands will often have something called flags. That -O that you see right there, that is an example of a flag. In this case, what it'll do is just take all that information you see at the top and then try its best to put it all on one line for us, which is handy. A lot of times, if you don't know all of the flags you can use for a command, you can do -H. Oops. This is an example where you can't do that. That's convenient. Okay. So, we got it all on one line. Let's see if we can grab the IP address. So I'm going to use a regular expression. Who here has not heard of regular expressions before? Cool, now I get to explain regular expressions. So the grep tool is one of many tools out there that'll use something called regular expressions for finding pieces of text. What it is a series of characters and numbers and letters that will help you identify patterns. Help you identify patterns in the text. So like if you wanted to find all of the people in a very big list of people that start with the letter J, right? Or you wanted to find all of the phone numbers and a list of phone numbers that have area code 318. In this case, let's see if we can grab any piece of text that begins with this. Do I want to do that? Let's see if we can grab all of this. So, when I say grep, I want to look for the pattern inet space, and then this isn't a full regex tutorial, but in this case what I'm going to do is dot any amount of times. So in regex, you have special characters, and those special characters will help you identify what patterns you specifically want to look for. Because I could just say, oh, look for right? And then find any text that specifically has that word in it. But let's say I wanted to find any line that has a J followed by any. That's a little necessary. Right? This would identify something very specific. This would look for patterns. And in regex, period means any character. Right? So if I just type the letter J, it'll only find letter J, right? If I do the number 5, it'll only look for the character 5. But a period says I can do J, 5, any number any number you want, any character you want, any letter you want. And then that asterisk so let's say I wanted to look for 3 J's in a row, right? I could do that. I could look for any number, 3 J's in a row. But what if I wanted to look for like 500 J's in a row? Well, I mean, I guess I could do J, J, J over and over again for 500 times. Or I can just do J. So then I'll say, okay, look for a J, and you can find either J, I think 1 time, you can find J 20 times, or you can find in the text J 500 times. Sorry, this isn't a regex presentation, but oh, thank you, Jacob. Regex. Okay, so I want to find inet, because we're looking for this text in particular, followed by any characters, and I want to try to finish it off at that. So let's say inet space any number of characters followed by a slash, and then just to make it simple, cool, let's see if that works. Oops. Another flag. Cool. So grep has a cool little flag. So grep by default, when it finds a match, it'll return the entire line that you're looking at, right? So if I was going through, let's say, a book, and I want to find any line that has the word the in it, it would go through every line and say, okay, here's a whole line that has the word the in it, here's another whole line with the word the in it. But in this case, I don't want the whole line, I just want the specific piece of information that I'm looking for, that specific pattern that I'm doing a regex for, which is what that -O flag is.
Does grep have his own like kind of regex language or something? Like you tried \S and it didn't seem to do space, \D wasn't. It didn't seem to do numbers, and I tried the character set 0-9 plus, and it didn't seem to like that. Like does it have its own quirks about how you have to do that?
Try -E.
Okay.
I remember in Dr. Abdullahi's class, he would always put a dash E in front of grep, and I was like, well, why are you doing that? Well, like, why do you need dash E? Well, so that dash E stands for extended grep. So the original version of grep has a very limited pattern searchable ability. But with that dash E, you can do some crazy stuff with grep.
Must be better. It still doesn't seem to like certain things. Still stuff is better.
We'll come back to you. Let's see. Let me just go. Okay, so we have the information we want, but we need to get rid of that inet word. I mean, we can keep it, but I don't really like it. So let's use a tool called cut. So cut is a lot like in Python. If I wanted to let's say we have the string hello world, and I wanted to split it right down the middle. Kind of like that. I would do dot split. I would do dot split. In bash, you can use cut. That's exactly what we'll do. So I'm going to say cut dash D space, because I want to take that string that I'm getting, inet followed by the IP, and then cut it right where that space is. And then I want to also specify what part of that now split string that I want, because it could give me the word inet, or it could give me the IP. So to get the IP in that inet, I'm going to say dash F2. So that's another flag. Dash F means field. So it'll take your string and split it into fields, kind of like cells in an Excel sheet. Which Excel cell would you want specifically? And in this case, I would say 2. I want that second one. I know in pretty much every language, if you wanted, say, the first item in an array, you would say 0. I want the 0th object in the array. But in Bash, a lot of times, you'll actually have, like, you won't use the 0 one. The first one would be 1. So, and because of that, I want the second field. And there we go. There is our IP address. I'm just going to copy and paste that whole line.
We can also use cut again to get rid of /21 if we want.
We can. I was thinking about doing that, but it's already 6:46. Let's not have too much fun. Okay, so now we have our IP. We have this whole command that we're going to put inside of this command substitution. Again, if I want to take a command like this and save it into a variable, I have to do a command substitution with the $ parentheses. You know what I forgot to explain? The pipes. So y'all are following along great, but notice how I did the IP command and then I followed it up with this, like, they call it a pipe. So on my keyboard, the backslash, if I do shift backslash, it'll give me that vertical line. So what that means is, let's say, I wanted to give Clay here a marker. what we could do normally is, so what we could do normally is, I say, Clay, I want to give you a marker. There you go, get it. Right? And so that's how processes normally kind of communicate when they're on side of the same system. They have to have a shared space to grab things. They can't just like directly pass each other stuff. In this case, we use something called a pipe. And that's what this symbol represents. Coincidentally called a pipe. On Linux, there's two kinds of pipes. There's named pipes and unnamed pipes. And this is an example of an unnamed pipe, right? So going back to Clay. Hey, Clay. So I have a marker I want to give you. Before I give it to you, I want to name this table John. There you go.
Thanks, John.
On Linux, we don't have to do that. We can just use an unnamed pipe, kind of like before where I just set it down and gave it to him. And that's what this represents. So I have the IP command. I get that specific line that I wanted, or that specific device that I wanted. And then it takes all of that output and then gives it to the grep command, right? And then grep, it can't just take it directly from IP, so Linux will take the output of IP and store it into kind of a temporary storage space for grep to grab. And that's what an unnamed pipe is.
Question on that.
Mhm.
Is that pretty much like IPC, inter-process communication, essentially? I mean, the named pipes and all, I mean, that's what's used for it. So essentially that's what's happening. Huh? A very easy way of doing that, just with one symbol.
Yeah.
It's so powerful, but
Now, I will say, I think IPC is actually like a different standard, but yes, that is inter-process communication in its general form.
never thought of it like that. That's a good way to think about it.
So you can pretty much do this as many times as you want. So let's say I didn't just stop at get that big body information, grab that pattern, and then cut it. I mean, I could follow this up with as many pipes as I want. Like Dr. Cherry said, I could even do another pipe to split it. Cut minus D by that backslash, and then grab that first field. Oh, we did get it. What is going on? Oops, I accidentally copied the IP. So yeah, you can add as many pipes as you want to refine your output as much as you want. In this case, we took off that /21 at the end, and now we just have the IP. Cool. I'm going to go ahead and skip the getting the gateway information. It's pretty much the same thing. Let's try to get our external IP real quick. So let's see, external IP. So anytime, let's say, I have a computer in another country, another continent, right? When it goes through the internet to try to talk to my computer, it has to go through this gateway first. And this gateway, a lot of times, especially on home networks, this has a public IP as well. So if this guy wants to talk to this guy, it says, hey, I want to talk to you. But in reality, it's talking to this guy. And this guy will kind of be the mediator between him. So, our local computers don't actually store our external IP. So in order to do that, the way we could do it is, let's see, what I like to do is use the curl command. Let's see if that works. Cool. So that's another cool tool in Bash, curl. It basically does the same thing your web browser does. So when I go to, let's say, google.com, I go into my web browser in the search bar, type http google.com. and then Google will respond with a web page. But it doesn't have to respond with a web page. It could just give me some sort of data. In this case, that's what's happening. So I'm talking with this website, ifconfig.me, and what it does is it gives me my external IP. And you can do this all from the command line. In this case, my external IP happens to be my current IP. That's just how text network works.
You go to a browser, they give you a lot of other information.
What's that?
You go to ifconfig.me in a browser, they give you some other code things you can try.
Yeah, you don't have to just use it from the command line. If you do go to this website, it's really useful for testing your internet connection or kind of what you look like on the outside world. Oops. Let's say -s. Cool. What I did there was use another flag, -s silent. Sorry about those Discord messages. Because I had to have Discord open.
Close it down.
And that'll just make the outputs out for me. So some flags in Linux, flags, a lot of times they'll either be a single dash followed by a letter, or a double dash followed by a word. That's what it is in this case. Okay, so how are we feeling? Okay, cool. Did anyone have any problems that they were following along with me? No, cool. I will apologize if that was kind of a presentation. Bash is kind of boring, I will admit, and kind of aggravating, because if you ask me, this whole line is not intuitive. It is just not as cool as if you were to do it in Python. But one of the reasons why you might do this over Python, well, let's say I get a new computer from my boss, but it doesn't have Python installed on it. Oh, well, we can't install Python. It's not authorized to be installed on your computer. Well, you have Bash. Bash comes by default on a lot of Linux distributions, and Linux is one of the most common server distributions. So it's worth at least knowing about. So, Bash is very difficult. So if you want to get into Linux or server administration or IT or software development even, because a lot of people automate their build process or their installation process, make sure to practice, because again, this isn't even the worst of it. There's a lot worse stuff than this.
So if you put a backslash, you can escape the new line and break it up in different lines, so it makes it a lot easier to read.
Where's that at?
Like on line 3, if you want to break it, say on the pipe.
Oh, yeah.
Backslash, escape the new line, go to the next line, and then I'd make sure there's not a space though after that, because otherwise it's going to escape the space at the end of the line. No, after the.
Oh,
like that, yeah.
there
get
we
rid
go.
of those. Yeah, now it should work. Yeah.
Cool. So yeah, do I have any questions real quick in the last 3 minutes of this presentation?
How do you use power?
First of all, you don't need touch.
Yeah, you use Bash, of course. My favorite color is purple. Well, I felt like someone wanted to ask that, but was too shy.
I was wanting to, but
Do you prefer contacts or glasses?
Glasses. Yeah.
Wear glasses.
Cool. Well, y'all are free to go and spread your Bash knowledge, or talk about how much you hated Bash.
it's interesting. I'll
technically not a language.
Oh, you're right, you're right.
Programming languages.
I would not put the word intuitive with bash. Don't put those two.
You can now put bash on your resume.
Yeah.
It's on the resume.
I was very impressed. I'm thinking about hiring such a gentleman. Just
Really?
Yeah.
I can turn off with this.